we are going to be presenting a project on the topic predictive modeling for personalized diabetes care using diabetes health indicators data. I am Smriti, and along with my group members Aatman and Vatsal, we will take you through the key aspects of our project. So, our presentation will be covering the introduction, methodology, and the current progress. Starting with the introduction, let's start by acknowledging the scale of diabetes epidemic. According to the International Diabetes Federation, it's estimated that 693 million people will be affected by diabetes by the year 2045. So, diabetes is a chronic condition which disrupts blood glucose regulation, resulting in high blood sugar levels. So, this is a condition where the body either doesn't produce enough insulin or doesn't normally respond to insulin. So, this disruption in the body's natural process leads to abnormally high blood sugar levels. The symptoms of diabetes include urination, dry mouth, excessive thirst, and unexplained weight loss. Since these symptoms are not always readily noticeable, it leads to delayed diagnosis and potential complications. The rationale of picking this project is to create machine learning models, and this technology offers personalized approach by analyzing various factors such as lifestyle, general health, BMI, and age. So, machine learning models provide a pivotal role in predicting individuals' diabetes risk by considering multiple data points. So, this not only enhances the accuracy of predictions but also facilitates the identification of high risk individuals early in their health journey. This not only improves patient outcomes but also enhances adherence to healthcare regimes.
Hello, I am Aatman. I'll be moving forward with dataset overview. So the data was acquired from the Behavioral Risk Factor Surveillance System, that is BRFSS, a health survey conducted by CDC. The dataset contains around 70,700 responses from the survey, consisting of questions directly asked to participants. The target variable is diabetes binary, which has two classes, that is 0 and 1. 0 is for non-diabetic and 1 is for diabetic. The dataset has 21 features, which includes BMI, cholesterol, high blood pressure, age, sex, etc. Moving forward, we have this graph which was devised during the EDA process. It is the correlation of the diabetes binary with other attributes in our data. From this graph, we have key attributes that are general health, high blood pressure, BMI, diff walking, which is when an individual has serious difficulty walking or climbing stairs, age, and high cholesterol. Moving forward to the methodology, the workflow that we have devised is it starts with data collection from BRFFS data. Then we will go to pre-processing, that is cleaning, that involves removing duplicate rows and moving forward with EDA. Then we go to data visualization, where we create histograms, bar plots, box plots, and correlation metrics for different attributes of our data set. Then we go to feature selection, where we will be using standard scaling and one-hot encoding. Then we move to building machine learning models. Then we will using that machine learning models to predict and then later access their accuracies. The predicting modeling step generally includes the model selection, that is choosing from the variously available machine learning models. Then comes hyperparameter tuning. Then there's model prediction, that is predicting the model on the test datasets after it's being used for trained datasets. Then it then we will be doing model evaluation, that is using measures such as accuracy, precision, F1 score, and confusion matrix to evaluate the created model.
Hi, this is Vatsal, and I'll be discussing the current progress that we have made until now. So, based on the features that we have analyzed through EDA, we can see the count plot of general health ratings, wherein you can see that a rating of 3, that is in a good scale, leads to more people being susceptible to diabetes. Whereas through the box plot, you can see that people having ratings between 2 and 3, that is in a very good rating, do not have the risk of getting a diabetes. So, this is a significant factor in determining the same. Again, we have analyzed BMI category, that is the body mass index, categorized into four different classes: underweight, normal weight, overweight, and obesity. Wherein you can see that people having higher obesity levels are more prone to getting diabetes compared to people having normal weight. So that's also a significant factor. Again, high cholesterol levels are also a factor that can lead to diabetes, as you can see through the stack bar plot that we have generated. Next, we have categorized ages into different categories such as 18 to 24 up till 80 years. And there's a general trend that as the age increases, the probability that a person will get diabetes increases as well. And you can see that around 60 to 65 years old aged people are more likely to get diabetes as compared to people who are less older than them. Next up, after analyzing these visualizations, we developed machine learning models, and we found out that artificial neural networks, that is ANN, perform significantly better than the rest of the models, having an accuracy of 75.62 percentage. We are still devising methods that can lead to more higher accuracies in the project. But as you can see from the training versus validation loss, the as the number of epochs increases, the training loss significantly decreases. However, the validation loss is a bit stable, but we will be devising models that can lead to a much lower validation loss as well. However, the training accuracy increases significantly as the number of epochs increases, and through the confusion matrix as well, you can see that the model quite nicely predicts true positives and true negatives. So in the end, I would like to conclude by saying that we are devising a web-based application based on the machine learning models that we have trained, which will take user inputs and then predict whether the person is diabetic or not, and thus giving personalized solutions to them. So thank you.